Welcome to Lab Tutorials. Today we'll quantify ammonium ions using indophenol salicylate colorimetric method and a calibration curve. A calibration curve links known concentrations of a standard to their measured absorbance, so unknown samples can be quantified. You'll need an analytical scales, volumetric flasks, pipettes, beakers, graduated cylinder, lab spoons, funnel, a magnetic stirrer, and a UV-Vis spectrophotometer. You will also need ammonium chloride, colouring agent, and alkaline solution. Step 1. Prepare the stock solution. Weigh 0.9548 grams of ammonium chloride, or close to that number. Dissolve in a beaker with distilled water while stirring on magnetic shaker. Then transfer to a 250 millilitres volumetric flask, label clearly. Precision here controls your entire curve's accuracy. Step 2. Prepare working solutions by accurate dilutions of the stock. Working solution 1 is 50 times diluted standard stock solution. To prepare it, measure 2 millilitres of stock solution in 100 millilitre volumetric flask and fill up to mark. Working solution 2 is 4 times diluted working solution 1. To prepare it, measure 25 millilitres of working solution 1 in 100 millilitre volumetric flask. And fill up to mark. Mix well. Step 3. Make the calibration series and a blank. Your series will include 5 standards of 0.2, 0.4, 0.6, 0.8, 1.0 milligrams per litre of ammonium ion by pipetting 4, 8, 12, 16, 20 millilitres of working solution 2 and making to the mark. Be careful, adding too much of distilled water will ruin the whole curve and you will have to do it all over again. Pour 40 millilitres of each standard calibration solution to individual 50 millilitre volumetric flasks. Add 4 millilitres of colouring agent. Then add 4 millilitres of alkaline solution. Then fill up to 50 millilitres with distilled water. And stir thoroughly. You should see a smooth, light to dark colour gradient with increasing concentration. If not, remake from the stock. Leave in a dark place for at least 60 minutes. Measure each standard and the blank at the 655 nanometer wavelength in 1 centimeter cuvette. Plot absorbance Y versus concentration X and compute the linear regression. Your curve must be linear, with R squared greater than or equal to 0.97 to pass. Build the calibration curve right once, and your unknowns will be easy. Accurate prep, linear curve, trustworthy results. Good luck in lab, and thanks for watching.